Write the following in scientific notation. So let's say we have 5,911,000,000,000. So to write this scientific notation, I need to move the 0 to after the first non-zero number. So let's count how many times that is. There's 3, 6, 9, 12. So I'd write 5.911 times 10 to the 12th power. For example B, we have 0.000000345. To write this number in scientific notation, I need to move the decimal back a total of 7 places. So I'd write 3.45 times 10 to the negative 7th power. In problem 2, let's write the following in ordinary numbers. So 3.24 times 10 to the 9th. So that means I need to move the decimal 9 times. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let's just plug in the zeros. Writing this as a traditional number with the commas put in, I end up with 3,240,000,000. Example B, let's take 2.741 times 10 to the negative 3rd degree. Because of the negative, I'll move the decimal forward 3 places. So that'd be 0.02741. Example 3, we are going to simplify the following. We have 4 times 10 to the negative 3 times 5 times 10 to the 6 times 2 times 10 to the 3rd. So remember, when multiply and divide scientific notation, we put the like terms together. So that's the 4, the 5, and the 2 will be multiplied. And then the 10s raised to their degrees. 4 times 5 times 2 should be 40. And then now I have the same base with 10, so I add my exponents for a total of 6. But this is not in correct scientific notation, so I rewrite 40 as 4 times 10 to the 1st degree. And again, combine my like terms to get 4 times 10 to the 7th. In 3B, we're going to practice some division with negative exponents. So in this problem, the first thing I need to do is get rid of those negative exponents by flipping the fraction. Next, I'm going to distribute the degree on the outside to all the terms inside. So that gives me 2 squared, which is 4, times 10 to the 14th power. And then I have 5 times 10 to the negative 6. And just like multiplication, now we need to combine like terms. So 4 divided by 5 times 10 to the 14th divided by 10 to the negative 6. 4 divided by 5 as a decimal should be 0.8. And then subtracting my powers, I got 14 minus a negative 6, which should be a positive 20. But this is not in scientific notation, so I need to fix that decimal and the 0.8, so it's 8 times 10 to the negative 1 times by 10 to the 20th. Combining my like powers, I get 8 times 10 to the 19th degree. For example C, we're going to multiply scientific notations raised to degrees. So the first thing you want to do is distribute the power to each base inside the parentheses. So that's going to be 3 squared times 10 to the negative 10, since I multiply the exponents, times 2 cubed times 10 to the 15th degree. 3 squared is 9. 2 cubed is 8. Now, like in the last problem, we're going to put like terms together. So I'm going to take the 9 times the 8, times by the 10 to the negative 10, times by the 10 to the 15th. 9 times 8, that's 72. And then when I multiply, I add exponents. That gives us 72 times 10 to the 5th, but this is improper scientific notation, so I need to move that decimal. 10 to the 1st times 10 to the 5th is 10 to the 6th degree, so it's 7.2 2 times 10 to the 6. All right, let's do one more scientific notation problem. This is going to be a division problem. So I just need to combine my like terms. So it's going to be 4 divided by 2. Times by 10 to the negative 5th divided by 10 to the negative 3rd. So 4 divided by 2 is 2. And then I subtract my exponents to get a negative 5 plus 3, which is negative 2. Example 4, we're going to expand and simplify the following polynomials. For part A, we're going to have 3x minus 5 quantity squared. So we're going to use our perfect square expansion procedure to figure this one out. So that's my first term squared minus 2 times my first term times my last term plus my last term squared. Multiplying this out, I get 9x squared minus 30x plus 25. In example B, we're going to use our product rule, or sometimes referred to as the flow method. Take our x times our 4x, first terms multiplied together, gives us 4x squared. Our last term, our outside terms multiplied together, gives us negative 5x. Our inside terms multiply together for a plus 8x. And then, of course, our last terms multiply together for a negative 10. Combining our like terms in the middle, we end up 4x squared plus 3x minus 10. Example C, I notice that both of my terms are exactly the same except for the sign in between in the binomial. One's a plus, one's a minus. So this is the difference of squares method. So that means I take my first term and I square it minus my second term squared. So distributing the square to each of my bases, I end up with 25x squared minus 36. In part D, we're going to multiply two trinomials together. So to do this, we're going to use the distributive property, and we're going to distribute the x squared to each of the terms in the second parentheses. So it gives me 2x to the 4th plus 5x cubed minus x squared. Next, I want to take the negative 4 and distribute it to every term in the second set of parentheses. So that gives me a negative 8x cubed minus a 20x squared plus a 4x. And last but not least, I'm going to take the 5 and distribute it to each of the terms in the second parentheses. Starting with a positive 10x squared then a positive 25x minus 5. Combining all my like terms, my final answer will be 2x to the 4th minus 3x cubed minus 11x squared plus 29x minus 5. In example E, we're also going to use the distributive property, but we're going to distribute to each individual binomial term. Starting in the first one, we're going to distribute the 5 to each of the terms in the parentheses, which will give us 5x plus 10. For the second one, we're going to distribute negative 3 to each term in the parentheses. That gives us a negative 12x plus 9. Finally, we're going to take the 2, distribute to each of these terms for a 2x plus an 8. Next, combine our like terms, the 5x, the negative 12x, and the 2x. And then combine the numbers, so that's going to be a plus 10, plus 9, plus 8. Adding these terms together, we'll get a negative 5x plus a 27. For example F, we're going to multiply 3 binomials together. So you're going to do this step by step. You're going to start with the first two binomials, and you're going to multiply it together using the full method. So that will give me a 2x squared minus a 5x, and then multiply my inner terms together, plus 6x, and our last terms together is a negative 15. Next, I'm going to bring down that 3x minus 1, since I haven't used it yet, and combine my like terms in the first parentheses for a 2x squared plus an x minus a 15. Finally, I'm going to use the binomial at the end and distribute each of those terms to the trinomial in the front. Let's see, that gives us a 6x cubed, and then a 3x times an x is plus 3x squared, and then 3x times a negative 15 is negative 45x. Now distribute the negative 1 to each of the terms in the trinomial. So that's going to be 2x squared times a negative 1 is negative 2x squared. Negative 1 times x, well, negative x. And a negative 1 times negative 15 is a positive 15. Combining my like terms, I will end up with 6x cubed plus x squared minus 46x plus 15. Let's put an example G over here to the side. In this example, we're just going to use the distributive property. We're going to distribute the 4x to each term of the trinomial. That gives us an 8x cubed, and 4x times a negative 9x is a negative 36x squared plus a 12x. For example 5, we're going to practice our binomial theorem. So let's remember Pascal's triangle. Okay, I wrote Pascal's triangle over to the side to the 7th row. I decided to stop at the 7th row since I ran out of room on my paper, but this can continue on as far as we want to. So looking at example A, I'm looking at the binomial cubed, so that means I need to go to row 3 of Pascal's triangle, which would be 0, 1, 2, 3, this row here. And that's going to tell me my coefficients, at my first coefficients. So I have 1 times my first term, which is 2x, raised to the 3rd degree, times by my second number in the binomial, which is positive 3. That's 3 raised to the 0 power. My second term, I take the second number in Pascal's triangle, which is 3. Again, times it by my 2x raised to, and this time my power needs to be 1 less than the last one I used, so that'd be a 2. And my last term of 3 raised to 1 more power, so I'd raise it to the first. To find the third term in our answer, we are going to look at the third number in row 3 of Pascal's triangle, which is a 3. Times it by our first term in the binomial of 2x, raised to the 1st degree, times by the second term in our binomial, which is 3, raised to the 2nd degree. And our last term is going to be the 4th number in Pascal's triangle for row 3, which is 1, times by my first term raised to the 0 power, times by my last term of 3 raised to the 3rd power. Now I'm just going to simply simplify each of these individual terms. We know 3 to the 0 is 1, and I know that 2x cubed is the same as 2 cubed times x cubed. Then I have 3 times 2 squared times 3 times x squared, plus we have 3 times 3 squared, which is 9, times 2 times x, plus anything to the 0 power is 1, so I got 1 times 1 times 3 cubed, which is 27. 2 cubed is 8, so that first term becomes 8x cubed. My second term, after multiplying 3 times 2 squared together, I get 36x squared plus 54x plus 27. Let's do one more binomial. So let's take 3x minus 1 to the 5th degree. So now I need to look at row 5 on our Pascal's triangle. First term in row 5 is 1, times it by 3x to the 5th degree, times by a negative 1 to the 0 degree, plus the second term in row 5 of Pascal's triangle, which is 5. This time the 3x will be raised to the 4th power. The negative 1 is to the 1st degree. For my third term, I'm going to take the third number in Pascal's triangle from row 5, which is 10, times it by 3x to the 3rd degree, times it by negative 1 to the 2nd degree. Now to the 4th term, we'll look at the 4th number in row 5 of Pascal's triangle, which is also 10. Multiply by 3x to the 2nd degree. Finally, times by negative 1 to the 3rd degree. The 5th term, my answer would be found by taking the 5th number in Pascal's triangle from row 5, which is 5, times by 3x to the 1st degree, times by negative 1 to the 4th degree. And my last term, take my last number in row 5 on Pascal's triangle, times that by the 3x raised to the 0 power, multiply by negative 1 to the 5th power. All that's left to do now is to simplify. Okay, for each of these terms, we're going to simplify by distributing that degree to each of the bases. So for each of these problems, we're going to simplify by distributing our power to each number inside that base, combining like terms and simplifying our final answer. We end up with 243x to the 5th minus 405x to the 4th plus 270x cubed minus 90x squared plus 15x minus 1. In problem number 6, we simply state how many terms you would have before simplifying. When you're multiplying two polynomials together, like in example A, you simply count the number of terms in each of the polynomials. My first polynomial has 5 terms, and I'm multiplying that by my second polynomial with 4 terms. So to figure out how many terms my unsimplified answer will have, I take 5 times 4 to get 20. My answer before simplification should have 20 terms.